We're now ready to start learning how to break vectors into components. We're now going to learn how to resolve a vector into components. Here's a vector. Now this is very similar to the vectors that we've been dealing with for the last few minutes in these videos, but now I'd like you to actually calculate what the components are. So try to pause the video and actually calculate the x and the y components. Don't worry if you get stuck. If you get stuck, just restart the video and we can go through it together. The first thing we have to do is draw the components. Well, that means drawing one of those right triangles. We have to draw a right triangle that uses the overall vector as the hypotenuse, that has legs that are parallel to the axes. And it would be nice if it could include this angle that we were given. Well, here we go. We have a right triangle that's using the overall vector as the hypotenuse. Each of the legs is parallel to one of the axes, and it's including the angle that we were given. Let's label the sides. Well, this is our x component because it's parallel to the x-axis. And this is our y component because it's parallel to the y-axis. All right, now we have to proceed to try to calculate the components. Well, what we have to do now is remember all the trig for physics that we learned earlier in the videos. We have to start using some of the trig that we learned earlier for physics. One thing that we've learned to do is use an asterisk to indicate the information we were given. So this asterisk indicates we were given this overall magnitude, and this asterisk indicates not just that we were given this angle, but that we're going to be focusing on this angle. It makes sense to focus on the angle that you were given. It would be kind of weird to focus on this angle. We could figure out this angle if we wanted to, but that's not the way these are conventionally done. Usually you use the angle that you were given. Now we can label the hypotenuse and the adjacent side and the opposite side. The asterisk helps us to keep track of who's adjacent and who's the opposite side. Now would be a good time to write down our mnemonic for the trig functions. SOH CAH TOA. So here's our mnemonic for the trig functions. SOH CAH TOA. So which trig functions does it make sense to use here? Well, clearly we want to use the information that we were given, indicated by this asterisk. We want to use the information we were given about the hypotenuse. We're going to use the information we were given about the hypotenuse. Well, it would make sense to use the sine, because that refers to the hypotenuse. And it makes sense to use the cosine, because that refers to the hypotenuse. It would seem kind of weird to use the tangent, because that doesn't refer to the hypotenuse. And the hypotenuse is the information that we have. Well, we know CAH. The cosine is the adjacent side over the hypotenuse. Cosine is adjacent over hypotenuse. I'm not going to plug into this yet. Instead, I'm going to solve this for the adjacent side. After all, we're trying to find the adjacent side. How can we start solving this equation? Well, we know that to get rid of the fraction, we want to cross multiply. So let's cross multiply. When we cross multiply, we're multiplying diagonally. 1 times the adjacent side just gives you the adjacent side. And then multiplying diagonally in the other direction gives the hypotenuse times cosine 53. We know that the cosine is the adjacent side over the hypotenuse. So if you want to find the adjacent side, you can cross multiply and you'll get that the adjacent side is the hypotenuse times the cosine of theta. To save room, I'm just using A for adjacent and H for hypotenuse. That's what we have here. Adjacent equals hypotenuse times the cosine of the angle. Here I'm just using theta for the angle. I think I've mentioned a number of times in these videos that when people start to get comfortable with the trigonometry here, they usually don't write this formula down. They just go straight to this formula. And we're going to start doing that now at this point. Generally speaking, notice that, remember that we're always going to use the overall vector as the hypotenuse. When we're breaking a vector into components, we need to draw a triangle that has the overall vector as the hypotenuse. That means we're going to be using the sine and the cosine functions, because those deal with the hypotenuse. Well, it turns out that if you work out the math, the adjacent side is just the hypotenuse times the cosine. So we might as well just go straight to this equation over here. Now, you don't have to start doing this if you're not comfortable with this yet. I'm going to be doing it on the board, but you don't have to do that. If you ever forgot this formula, it should be easy to figure it out again by going back to cosine equals adjacent over hypotenuse. So I don't want you to forget SOH CAH TOA. The cosine is the adjacent over the hypotenuse. Cosine is adjacent over hypotenuse, and then with a little bit of cross multiplication, we can find that the adjacent side is the hypotenuse times the cosine. So even though when you're solving problems, it's usually faster to start with this equation, if you ever find yourself uncertain of the equation or confused, go back to first principles and say that the cosine is the adjacent over the hypotenuse. Now the adjacent side here is what we're going to call v sub x. All right. However, let's think about this for a second. When we're using trig functions, when we refer to the adjacent side here, are we referring to the sine component or just the magnitude of the component? Well, trigonometry is about geometry. It's about lengths. This is supposed to be the length of the adjacent side. Well, a length could never be negative. It doesn't make sense to say that the length is -5 or -6. Lengths are always positive. In geometry, we're working with positive numbers, positive lengths. So we should not really be plugging in the signed component here. We should be plugging in the magnitude of the x component. This adjacent side here represents the length of the adjacent side. If I was going to write this out in more detail, I would say that this is the length of the adjacent side equals the length of the hypotenuse times the cosine of 53. So it doesn't make sense to use a signed number for this, because lengths are always positive. So it doesn't make sense to use v sub x for this symbol. We should use v sub x with a dot to show that that's a magnitude. I know this might seem like a trivial point right now, but I think that being very careful about the symbols here can really save you a lot of grief later on in the course. So I really am encouraging you to get into the habit of using v sub x when that's appropriate and using v sub x with a dot when that's appropriate. And then we're going to see as you go through the course that that really helps you to get the signs right on problems where a lot of other students are going to get them wrong. Okay. So this represented the length of the adjacent side, so we need to use the magnitude of the component because lengths are always positive. Now we know that the hypotenuse is 5. I could plug in v, but why plug in v when I can just plug in a number? I can plug in 5 times the cosine of 53. Now we can do this calculation in one step on our calculator. 5 times the cosine of 53. That turns out to be 3. V sub x with a dot equals 3. So I'm going to be encouraging you to write this as v sub x with a dot, and then I'm going to be encouraging you to keep writing the dot as long as you're referring to the same variable. So this is v sub x with a dot. That's 3. Now there's no point indicating a sign here because remember that magnitudes are always positive, so we don't have to indicate their signs. But now we can go back and write down what's v sub x without the dot. What's the signed component? Well, it looks like we're not ready for that. It looks like we left something important out, didn't we? We forgot to put the arrows in here. We really should have done that at the beginning. Let's put the arrows in now. The overall vector was pointing up and to the right. The overall vector was pointing up and to the right. So the components should be pointing up and to the right. And now we can see that right is positive direction, and the x component is pointing right. So v sub x is going to be positive 3. The positive direction is to the right, and the x component is pointing to the right, positive in the positive direction. So we know it has a length of 3, and it's pointing in the positive direction. All right, so notice that when you're actually doing the trigonometry, you're just working with lengths and geometry. So you should be using the magnitude of the component. And then where does the sign come from? Well, the sign comes from getting the arrows correct. The trigonometry tells you the magnitude, and the signs come from the arrows. The trigonometry tells you the magnitude, so we should use a dot for that. And then the arrows tell us the sign, and then we write the symbol without the dot. As usual, I'm strongly encouraging you in your own work to try to imitate exactly the notation I'm using on the board, including the dots and including the signs.